Ready to try a new way to learn AP economics? Let's dive into today's lecture using AplusMap's mind maps. Get ready to study. Okay, let's unpack this. Have you ever noticed how some things just don't seem to get cheaper no matter what? When gasoline prices jump, people still kind of fill up their tanks, right?
Yeah, they grumble, but they still buy it.
Exactly. But then if your favorite brand of, say, designer handbag suddenly goes on a deep discount, suddenly everyone wants one. Sales just explode. What's behind that difference? How we react?
That's the core question, isn't it?
It is. So today we're doing a deep dive into a really foundational concept in economics. It helps us understand exactly how much things change when prices or even our incomes shift. It's called elasticity. And our mission here is to take your source material and really pull out the key stuff, the core ideas, the formulas you kind of need to know, and, plenty of real-world examples. It's about getting well-informed,
Yeah,
especially if you're maybe looking at this for an AP economics exam.
absolutely. And what's fascinating here, I think, is how understanding elasticity can truly unlock your comprehension of pretty much any market dynamic.
Right.
It helps you go beyond just knowing if something changes to understanding how much it changes. And maybe more importantly, why that specific amount matters for everyone involved, consumers, businesses, even governments. It's a really critical lens.
Okay, so let's start right at the beginning then. When we talk about elasticity, what exactly is that, like at its core?
Yeah, good place to start. Basically, at its simplest, elasticity measures sensitivity.
Sensitivity.
Yeah, think of it like how sensitive buyers or sellers are to changes in something, usually price, but not always, we're asking.
Yeah.
When the price moves, how big is the ripple effect? How much does the amount people buy or sell actually change?
Ah, okay. So it's not just if they react, but how much they react. Can you give me a quick way to sort of picture that sensitivity in action?
Precisely, it's the how much. So if something is elastic, it means buyers or sellers are highly sensitive, very responsive. A small price change causes a big reaction in the quantity bought or sold.
Like a rubber band? Yeah.
Exactly like a rubber band. It stretches a lot with just a little pull. On the other hand, if something is inelastic, it means they're not very sensitive. The price can shift quite a bit, but the quantity bought or sold changes only a little bit.
Okay, so more like trying to stretch something really stiff.
Right. Think of maybe a thick steel bar. It barely budges, even if you push or pull hard. That's inelastic.
Gotcha. Pause the screen for a moment and try the practice problems. The answers are at the end of the video. Okay, here's where it gets really interesting, I think, especially for understanding us, consumers. Let's zoom in on price elasticity of demand, PED.
PED, yeah, that's the big one.
This concept measures how sensitive buyers are specifically to a change in price. And for anyone really trying to nail this down, especially for that AP context, knowing the formula is key.
Absolutely essential.
It's the percentage change in quantity demanded divided by the percentage change in price. And remember, that percentage change calculation, super useful here.
Oh, yeah, don't forget that one.
It's just new minus old divided by old times the 100. That gives you your percentage. Can't calculate PED without it.
Right. And with PED, we actually break it down into 5 distinct types. Each one shows a different level of sensitivity, and picturing them really helps. Let's start with the extremes.
Okay.
Perfectly elastic demand. Now, this is almost theoretical, right? But it means the elasticity calculation comes out to infinity. Consumers are incredibly sensitive. A tiny price increase, like, literally causes the quantity demanded to drop straight to zero.
Wow. So like what?
Think about a single farmer selling wheat in a massive, perfectly competitive market. If they try to charge even a penny more than everyone else,
Buyers just go elsewhere instantly.
exactly, they have infinite other options at the market price. It's a powerful illustration of, well, extreme responsiveness.
Okay, makes sense as an extreme. What's next?
Then you just have plain old elastic demand. Here, the elasticity value is greater than 1. This still means high sensitivity. If the price goes up, you'll see a disproportionately large drop in how much people want to buy.
So things we don't strictly need, or things with lots of options.
Exactly. Think luxury goods, like those designer handbags you mentioned, or non-essential items where you can easily find substitutes. If your favorite streaming service hikes its price too much, you might just switch, right?
Yeah, easily.
The key is the percentage change in quantity is bigger than the percentage change in price.
Okay. And the middle ground.
That's unit elastic demand. Here, the elasticity equals exactly 1. It's what we call proportional sensitivity.
Meaning?
Meaning, if the price changes by, say, 10%, The quantity demanded changes by exactly 10%. It's a perfect match in percentage terms.
Any examples?
Well, movie tickets are sometimes used as a sort of example, but honestly, finding something perfectly unit elastic in the real world is pretty rare. It's more useful for economic models, really. It shows that exact one-to-one relationship between the price change percentage and the quantity change percentage.
Right, a theoretical benchmark again, kind of.
Sort of, yeah. Now, moving towards less sensitivity, we hit inelastic demand. Here, the elasticity value is less than 1.
So not very sensitive.
Exactly. If the price goes up, you'll only see a relatively small drop in the quantity demanded. Think about necessities. The gasoline example is perfect.
Yeah, you still need to get to work.
Right. Or essential medicines. People tend to still buy them, even if prices rise quite a bit, because, well, they have to. In these cases, the percentage change in price is bigger than the percentage change in quantity.
Okay, that makes intuitive sense for things like gas. And the other extreme.
The total opposite of perfectly elastic. Perfectly inelastic demand. Elasticity equals 0. No sensitivity. None.
Meaning the quantity bought doesn't change at all.
At all. Price can go way up or way down. Quantity demanded stays exactly the same. The classic example here is a life-saving drug, like insulin for a diabetic.
Right. If you need it to live, the price almost doesn't matter in terms of whether you buy it.
Precisely. You'll buy that required amount regardless of the cost.
Okay, wow, 5 types. Now, if you're a visual learner, like me, take a second to actually picture these 5 types as demand curves on a graph. They're super helpful for seeing elasticity.
Oh, definitely. The visuals make a huge difference.
For perfectly elastic demand, that extreme sensitivity, the curve is just a flat horizontal line, right? It shows consumers will only buy at that one specific price. Anything higher.
Demand disappears. Poof!
Right. And then perfectly inelastic, the zero sensitivity one, gives you a completely vertical demand curve. Price can go anywhere along that line, but the quantity
Stays fixed, locked in.
Yeah, and for regular elastic demand, the curve is relatively flat, isn't it? Showing that a small change in price, vertical, leads to a big change in quantity, horizontal.
Flatter means more elastic.
Whereas for inelastic demand, it's much steeper. A big price change only causes a small quantity response.
Steeper means more inelastic, less response.
And unit elastic is usually shown as a specific curve, not perfectly flat or steep. But the huge takeaway here, and this is big for understanding the graphs you see, is that the slope of the demand curve reflects its price elasticity.
That's the money concept right there. Flatter curve, more elastic. Steeper curve, more inelastic. It's a core idea that really connects the numbers to the picture.
Okay, so we've spent a lot of time on how we as buyers react, but what does all this mean for the businesses trying to sell stuff to us? This is where the total revenue test comes in, yeah. And that seems pretty vital for producers.
Oh, absolutely vital. First, just remember what total revenue TR is. Simply the price of the good multiplied by the quantity sold, P times Q, GR equals PXQ.
Right.
Now, what's really cool and incredibly useful for businesses is how your demand curve can basically be split into 3 zones based on its elasticity. And each zone tells you something completely different about what happens to your total revenue if you change your price.
Okay, lay it out for me, zone 1.
Let's start with the elastic zone. If your product has elastic demand, meaning people are sensitive to price changes, then lowering your price will actually increase your total revenue.
Wait, lower price, more revenue? How?
Because the increase in quantity demanded you get from that lower price is so big that it more than makes up for the lower price per item. You sell way more units.
The volume effect wins.
Exactly. The volume effect dominates the price effect. This is also where marginal revenue, a concept you'll dig into more later, would be positive. Revenue is still growing with each extra unit sold.
Okay, elastic zone, lower price, TR goes up. What's next?
Right at the unit elastic point, where elasticity is exactly 1. That's where total revenue hits its absolute peak, its max zone.
The sweet spot.
The sweet spot. Any change in price from that point, whether you raise it or lower it, will cause your total revenue to fall. And importantly, this is also the exact point where marginal revenue hits 0.
MR equals 0 at peak TR. Got it. And the last zone.
The inelastic zone. If your product has inelastic demand, people aren't very sensitive to price, then lowering your price will actually decrease your total revenue.
Okay, why is that?
Because in this case, the small increase in quantity you get from dropping the price just isn't enough to compensate for the lower price you're getting per unit. The price effect dominates the volume effect.
So you lose more on the price than you gain in quantity.
Precisely. And this is also where marginal revenue turns negative. Which brings us to a critical business insight. pulled straight from the source material. Never produce where marginal revenue is negative.
Why not?
Because if MR is negative, it means selling one more unit actually reduces your total revenue. You're literally losing money on that additional sale. It's like burning money.
Ouch. Okay, don't do that.
Definitely not. So this whole total revenue test is super important for businesses deciding pricing strategy. Should we raise prices? Lower them. It depends entirely on where on the demand curve you are in the elastic, unit elastic, or inelastic zone.
That explains why, say, a company selling essential medicine might raise prices and still see revenue go up, while a clothing store might need huge sales to boost theirs.
Exactly.
Yeah.
It's all about the elasticity of demand for their specific product.
Okay, great. We've hammered demand pretty hard. Pause the screen for a moment and try the practice problems. The answers are at the end of the video. What about the other side? The suppliers. Let's shift gears to Price Elasticity of Supply, or PES.
Good idea. PES measures how much the quantity supplied responds to a change in price. So now we're looking at the sensitivity of sellers to price changes.
And I bet the graphs work similarly.
They do. Just like with demand, the slope of the supply curve gives you a visual cue about its price elasticity. A steeper supply curve means supply is less elastic or more inelastic.
Meaning sellers can't react quickly.
Right. Maybe it takes a long time or it's very expensive to produce more, like build a whole new factory or growing crops. They aren't very responsive to short-term price changes.
And a flatter curve.
A flatter supply curve suggests a more elastic supply. Sellers can easily increase or decrease their output if the price changes. Maybe they have extra machines sitting idle, or can easily get more raw materials. Much more responsive.
Okay, so slope reflects sensitivity for supply too. Pause the screen for a moment and try the practice problems. The answers are at the end of the video. Now, here's where things seem to get even more connected. What happens to the demand for, say, coffee if the price of tea changes?
Ah, now you're talking about related goods. That brings us to cross-price elasticity of demand. You'll often see it as CPED or sometimes XED.
XED, okay.
And the definition.
It measures how the quantity demanded of one good responds when the price of a different good changes. So good A's demand reacting to good B's price.
And the formula follows that logic.
Yep. It's the percentage change in quantity demanded of good A divided by the percentage change in the price of good B.
Okay. Now, I get the feeling the result itself is important here, not just the number.
Absolutely. With XED, the sign of the result, whether it's positive or negative, tells you everything about the relationship between the two goods. This is super important.
Okay. So if the result is positive.
If XED is positive, the goods are substitutes. Think about it logically. If the price of Coca-Cola goes up, positive price change for B. People buy more Pepsi, positive quantity change for A. They substitute one for the other.
Like rivals. Exactly. Coke versus Pepsi, Netflix versus Disney plus AE, maybe iPhones versus Samsung phones. If the price of one goes up, demand for the other goes up. Positive relationship, positive XED. This is a really common concept tested on exams, by the way.
Good to know. And if the result is negative?
If XED is negative, the goods are complements. They're used together like teammates.
Like printers and ink.
Perfect example. If the price of printers goes up, positive price change for B, people might buy fewer printers, and therefore the demand for ink cartridges goes down, negative quantity change for A.
Or hot dogs and buns.
Yep. Or coffee and creamer. If the price of one rises, demand for the other falls. It's a negative or inverse relationship, hence the negative XED value.
Okay, substitutes are positive XED, complements are negative XED.
Got it.
That's super useful. Pause the screen for a moment and try the practice problems. The answers are at the end of the video. One more type to cover.
One more main one, yes. Let's look at how your buying changes not when price changes, but when your income changes. This is Income Elasticity of Demand, or YED.
Okay, makes sense. How does demand shift with income?
Precisely. The definition is, it measures how the quantity demanded of a good changes when consumer income changes. And the formula, you guessed it.
Percentage change in quantity demanded divided by percentage change in income.
You got it. Percent change, QDD, over percent change, income. Y is often used for income in econ.
And I'm guessing the sign matters here too.
Hugely important again. Just like with XED, the sign tells us about the nature of the good. If the result, the YED value, is positive, the good is classified as a normal good.
Normal meaning?
Meaning as your income increases, your demand for these goods also increases. It's, well, the normal thing to expect, right? When people get more money, they often buy more stuff, or maybe better quality stuff.
Like maybe buying steak instead of ramen noodles if you get a raise.
Exactly. That's a perfect example of shifting towards a normal good as income rises. Your source mentions when people get more money, they look for something better. That's the normal good effect.
Okay. And if the YED result is negative?
If YED is negative, the good is an inferior good. This is counterintuitive at first, maybe. It means that as your income increases, your demand for these goods actually decreases.
So you buy less of it when you have more money.
Right. The sources put it this way. Once people do not have enough money, they look for something cheaper. These are often those cheaper options. But once income goes up, people tend to move away from them.
Like maybe taking the bus when money's tight, but buying a car when your income rises? Demand for bus rides goes down.
That's a classic example of an inferior good. Bus rides, maybe cheap instant noodles, store brand items sometimes. Understanding this distinction between normal and inferior based on the sign of YED is definitely something you'll encounter.
Okay, wow. So we've covered 4 big types: PED, PES, XED, and YED. Price of the good itself, supply response, related goods prices, and income. That's a lot of elasticity.
Covers a lot of ground, yeah.
And there was one final sort of super important tip mentioned about tying it all together, especially regarding those positive and negative signs.
Yes, this is a really crucial point to avoid confusion, especially on tests. It's about when the sign matters.
Okay, break it down.
For price elasticity of demand, PED, and price elasticity of supply, PES, you typically ignore the negative sign if one appears in the calculation for PED.
Why ignore it for PED?
Because the law of demand already tells us price and quantity demanded move in opposite directions, so PED will mathematically always be negative or 0. We already know the direction, so we focus on the absolute value.
So just the number itself tells us the sensitivity.
Exactly. That absolute value tells you the magnitude or the degree of responsiveness. Is it elastic 1, inelastic 1, or unit elastic 1? The number is the key, not the sign, for PED and PES.
Okay, PED and PES focus on the absolute value for the magnitude, but
for cross-price elasticity, XED, and income elasticity, YED, the sign of the result absolutely matters. It's critical information.
because it tells us the relationship.
Precisely. A positive or negative value for XED tells us directly if goods are substitutes, plus, or complements. For YED, the sign tells us directly if a good is normal, plus, or inferior.
Ah, okay. So for XED and YED, we pay super close attention to whether the result is positive or negative because that's how we classify the goods and understand their connection.
You nailed it. That distinction is key. Absolute value for PDPs tells you how much, while the sign for XEDD tells you what kind of relationship exists.
Pause the screen for a moment and try the practice problems. The answers are at the end of the video. All right, we've just done a pretty deep dive into elasticity, huh? From how sensitive buyers and sellers are to price changes, all the way to how our income shifts affect what we decide to buy. And it's really not just theory, is it?
Not at all.
It feels like the hidden engine behind tons of business decisions, pricing strategies, government policies sometimes, and even just how we as consumers make choices every single day.
It really is woven into the fabric of the market. And if we connect this to the bigger picture, thinking about elasticity isn't just about memorizing formulas for an exam, though that helps. It's about developing an intuition for anticipating market reactions.
So like a practical skill.
Exactly. Next time you see a price change announced, maybe it's for your daily coffee, maybe it's a sale on a new phone, maybe gas prices move again, try to pause and ask yourself, how elastic is the demand for this product likely to be? What does that probably mean for the company selling it? Or even, what might it mean for broader economic trends? It changes how you see the economic world around you.
Got it, everyone. Hope you followed along with today's lecture. Now, let's break down those quiz answers and make sure everything we covered really sticks. You can grab the complete mind map Musica. It's a killer snapshot of today's lesson, plus a super detailed AP economics textbook at www.aplusmap.ai. Ready? Let's get into those quiz answers. We're confident that AplusMap will help you secure a great score on the AP Economics exam. Looking forward to our next class.